So now that we know some more control structures, let's figure out who's your best friend. Suppose you have a file that contains the name of the people who sent you text messages in the last month. The person who sent you the most messages is probably your best friend. As always with programs, we're going to create the test data first. So let's say there were 4 text messages. If we had 4 of them from person A, that person would be your best friend. If we had 1 from A, then 1 from B, then 2 from A, that would be 3 from A and 1 from B, and again, person A would be your best friend. Now the next case is a little trickier. What if we had 1 from A, then 1 from B, then 1 from A, then 1 from B? Well, that could be either A or B. We probably want to decide which. One way to decide that is to choose the one that gets there first. It doesn't really matter which way you choose as long as you're systematic about it. We could also have 3 from B and 1 from A. When that happens, we'd want person B to be the one who is your best friend, and of course we could have 4 messages from B's. Boundary cases we might want to consider include having 1 text message, and of course the ties case we've already talked about, and all of our messages coming from the same person. The first thing we need to do is design some methods. So one method we're certainly going to want to have is read addresses from file. The input for that will be the file name. Now you might think that you could put the file name as a constant variable inside the method, and that's true, you can do that. But because file names tend to change a lot, I find it useful to leave them in the main program and pass them as a parameter. It's easy to find things in the main program, particularly if you keep your main programs short, as we usually do. The output is going to be an array list of strings, because that's the only structure we have for storing a group of strings at this point. The next method would be find most common element. So there we're going to step through our array list of strings, which means we're going to need that as an input parameter, and we'll return a string. That will be the name of the person who sent you the most text messages. Now we haven't read from a file before, so this is a new trick we're going to learn. The good news is that reading from file is exactly like keyboard input using a scanner. So you create scanner file equals new scanner, new file, and then the file name .text in quotes. So the file name is a string. The only thing that's different than creating the scanner the way we've done in the past is this new file part. Now, the import should come from the API. So let's go and look and see where the file class is located. So I'm going to Safari, and I'm going to look up the Java API. We're using Java 7, but it really doesn't matter which version of the API you choose. All the classes are over here, so you do Control F, and that will bring up your find box, and you look for file. The word file is in a lot of class names, so you just keep clicking forward until you find the one which is the right one. It's this one right here. The place you find the import statement is right up here. So right at the top is where we see that the class file is in the java.io package. So that's where we're going to have to get that from. Files are expected to be in your project directory, not your source directory. Unfortunately, Eclipse tends to put them in your source directory because that's where we put our other files. So these are things you have to pay attention to. Files tend to be a little troublesome to get set up the first time, so we'll pay attention to all those details. Files have some special properties. If you think about the console and files are very much alike. For one thing, they're sequential. So with the console, when you're typing in characters, you get the next characters that are typed in. You can't go back and read in previous characters. The same thing is true of files, too. You read in things sequentially, one at a time, and you don't back up. Well, that's fine, because we have loops that do that. HasNextLine is a very important method to use in files. What it does is tells you whether there still is data left in the file that you need to open. So that's how we'll tell when we hit the end. This is how we can get data out of a file without knowing how much is in there to start with. Let's go to Eclipse and write some code. So there's our workspace. And we'll create a project. called my best friend. We'll get it opened, select the source file, create a class, which I'll also call my best friend, but with no spaces because it's a class name. And we'll do our little cleanup work that we do every time. So we had a message that was going to return an array list of strings that was called read addresses from file. The parameter was the file name. Now we're using the array list again, so we need to import that. So we import java.util.arraylist. We know we're going to need some other imports too, so let's put them there right now. We'll need our scanner. And we're going to need our file class, java.io.file. Now because we're up here, I'm going to take a little shortcut and import one more class we're going to need later. We're going to need java.io.filenotfoundException. We'll talk about exactly why we need that one in a few minutes. Now you'll notice that all of our classes that we're using come from two different packages. One is java.util and the other is java.io. There is another way that we can do these import statements that some people prefer. I'm going to show you that way because you may want to do it. Personally, I like this way because it's very specific about what classes you're using. But this is legal in Java too. Import java.util period asterisk. The asterisk is something that we call a wildcard in computer science. And what that means is that it will find anything that's in the java.util package. So some people get lazy and do that. The reason that I like to put the file names in there is that it tells you exactly which classes are used. So let's say the next version of Java changes the scanner a little bit. If I know the scanner is used in this class, it's very easy to tell from the import statements that I might have to maintain it. But I really don't care which way you do it. So we're going to create our scanner object. I'm going to call it file now because it's not the keyboard anymore. So here's the new scanner with a new file of the file name. You'll notice that immediately Eclipse went crazy. Lots of little red stuff all over the place. This may just be because we haven't returned our object yet. So let's do that. We know we're going to have to construct an array list of strings. I usually call those result. And then at the end, we'll return result. Eclipse is a little bit happier, but it's not really happy yet. Let's take a look at the error message over here. It says the file is never closed, which is true, and it also says there's an unhandled exception type file not found. So, as far as closing the file, that's how you solve that problem, file.close. It is important to remember to close files, and it's something that's very easy to forget. The reason you have to close them is your program's only allowed to have so many files open at the same time. So basically you're using up a scarce resource. And if you don't close your files, you eventually will run out of files to open. Programs tend to open a lot of files, particularly as they get bigger. And so managing that scarce resource is very important. But notice Eclipse is still not really happy yet. It still has a little red arrow. And what it's complaining about, although not very articulately at this point, is the fact that because we're using a file, there's a problem that can happen. Files cause lots and lots of trouble. They have a tendency to get misplaced and not open correctly. So in addition to having to remember to close the file, Java also has some protections in there that forces you to warn anybody who's using your method that it may not behave well because it may not find the file. The way we say that is throws file not found exception. And what it means is this method may not be able to find a file it needs, and so it may have to rely on you to help with the file name. That's what it's basically saying. Now, Eclipse will help you with where you need to put these things in, but essentially it's any method where you open a file and any method that calls a method where you open a file. In other words, this tends to propagate throughout your program. So here we go. Throws file not found exception. Now we're way off the screen at this point, so we'll indent that part. When we call this method from the main program, you'll see what happens. So let's create an array list, and we'll call this emails is read addresses from file of some file name. Of course, we should create a file name. So I'll call it email addresses.txt. If you're not accustomed to paying attention to file extensions, now is a good time to get used to it. So you've probably seen file extensions like .doc or .docx or PPT. Well, the ones we tend to use in programming are .java for Java code, .class. Now that one's created by Eclipse, so you don't actually see it, but you might see it in your directories if you look at them. The ones we use for reading files are .txt, which stands for text. So those are readable in something like Notepad or WordPad on a Windows machine. So let's go back and work on our program a little bit more. So you'll notice that read addresses from a file the program isn't happy with. Ah, look at that, we've made one of those mistakes again. We can't make a static reference to a non-static method. Well, we know how to fix that now. We make our method static. And now that it's happy about that, it's unhappy about something else. Unhandled file type, file not found exception. So that's Eclipse's way of expressing to you that you need to throw the file not found exception from the main program because the main program called the other method. Now, one thing I like to do when I'm creating files is to do a very simple read in first and then do what I want with the data. This handles all the problems with the file being located in the wrong position. So let's create a text file that we can use. To do that in Eclipse, you create new, and it says file. Now, here's a place you want to be careful. It needs to be in the project directory, not the source directory. So we can do that by clicking there, and the file name will be mytextmessages.txt. Remember to include the extension. Now this will create an empty file. So I'm going to create some data. This is about what my day texting looks like. Susan is one of my good friends and Missy is my sister. Notice it's very important that everything's spelled correctly. By using two names that had the same number of characters, it makes it a little easier to spot typos. Now I'm going to go to the File menu and save this file, because if we don't save it, the program won't be able to use it. So now we're going to go back and rename this to mytextmessages.txt. I went back and renamed this to mytextmessages, the same way I named the file. So at this point it should open correctly. But let's actually write a little loop to just quickly read through the file and make sure everything's working before we try to work with the data. So we'll have while, and we're going to have file.hasNextLine. So that checks to see if we've run out of characters in the file, and then we'll do file.nextLine. Notice I'm not even saving this anywhere. All I'm doing is making sure that we're reading the data correctly. Another thing we can do here if we want is to save this to a string and then print it out. We can do that because it gives us a better test to show that the program is working. Using system out println for debugging is kind of tacky. It's not the way we want to do it all the time, but it's okay for cases like this where we're just doing a quick check. So let's run our program. Now notice this time it wasn't waiting for us. So let's take a look and see what it read in. We have 1, 2, 3, 4 Susans and 1, 2, 3, 4, 5 Missies. Probably a good idea to go back and check the file. Just like everything else in computer science, it's easy to get off by 1. So we have 1, 2, 3, 4 Susans and 1, 2, 3, 4, 5 Missies. So it looks like our program is reading the text file perfectly. So now that we know that's all going perfectly, we can quickly add the data into the array. So we will have result.add name. At this point, we can run again, just to be sure. Now our program isn't going to do anything, but even though it's not showing us that it's doing anything, one of the things we know is that it didn't throw a file not found exception. So that means it was able to find the file successfully and able to read it in. So now that we have our data, the next thing we want to do is to find the most common name. That's another method. This time we'll remember to make it public and static. It's going to return a string and take our array list as a parameter. It doesn't really matter what you call the parameter as long as it's meaningful. To get Eclipse happy again, let's just return an empty string. That will get rid of those annoying red X's. And now we're at the point where we need a strategy. So let's think about how we can solve this problem. We could try to count the number of times the first person's address occurred, and then count the number of times the second person occurred, and then count the number of times the third person occurred. But that's getting into a very complicated structure for something that doesn't need to be that complicated. So let's think about a different structure. What if we took our array list and sorted it? At that point, all the names that are the same would be together, and we would be able to figure out how many times each name occurred by stepping through the array once. It's really a good strategy, even though it's tricky to get it set up. So let's go and look at it a little bit. Now, one of the rules that's very important to follow is when you're working with a non-trivial problem, do not try to program anything that you can't describe how to do systematically by hand. If you don't know how to do it by hand, you don't know how to program it, and then you should invest your time in figuring out how to do it by hand first, and then translating that into code. Sometimes people get so anxious to get some code done and to have it look like they're making progress that they start sort of randomly substituting things into programs. That is not a strategy that has much success. So here's a better algorithm. Now when I use the word algorithm, that's a very important word in computer science. And it actually is a scientific word that has a very specific meaning. We're not going to worry too much about the meaning for right now, but what you can think about algorithms as being a sequence of steps that solve a problem. That's a good place to start with the word. So the first thing we're going to do is sort the data and then count the number of times that each name has appeared. We're going to need to keep track of the previous name because that's how we'll know when we're starting with a new name or continuing with an old name. We also need to keep track of the maximum number of matches that's occurred so that we know if a new name has more matches than an old name, and we're going to have to keep track of the name with the most matches. So there's going to be a lot of data hanging around here. So let's think through how this algorithm would work. Here's our data. Now I've already sorted the data, so we have 3 A's followed by 4 B's. Let's trace through one step at a time how our algorithm might work. Our first element is A. There is no previous element at this point, and our current count should be 1, because we just have 1 A. Our max count then will also become 1, because that's the biggest one we found so far, and our max value will be A, the one we found. When we get our second A, it will match our previous A. That means the current count should be incremented to 2, which increments max count to 2, and the max value stays at A. Here's our third A. The previous is still A. The current count gets incremented to 3. The max count gets incremented to 3, and our max value remains at A. Here's the changeover. When we find our first B, our previous is an A, and that tells us we need to restart our current count at 1. Our max count stays at 3 because 1 is less than 3, and our max value is still A. When we find our second B, it now matches our previous value of B. Our current count gets incremented to 2. Our max count stays at 3 and max value at A because we haven't yet gone over that limit. Here's our third B. Our previous value is B, so that means we increment our current count. Now at this point our current count is equal to max count. So that's that troublesome tie case that we worry about. I just left it at A. You could change it to B. I don't really care which you do. And here's what happens when we get our fourth B. The B matches the previous B. That increments current count to 4. So max count then goes up to 4 and max value becomes B. Notice by creating this table, I made it possible to think through the computation and exactly what variables I was going to need before writing any code. Now it may seem like we spend a lot of time doing this, but believe me, this is much faster than hacking away at code and hoping that something will magically work. So let's go and implement the method. So we know that we're going to need a string that holds our previous value, and we know we need to initialize that to an empty string. Remember that 2 double quotes together is how we say empty string in Java. We know we need a current count, and that needed to be initialized to 1. We know we needed a max count, and that needed to be initialized to 0. We know we needed a string for max value, and that needed to be initialized to the first element in the array. So that's addresses dot get 0. So now we have our variables set up. One variable was each column in the table. So we're going to loop through our array. So we're going to have while current count. Whoops, whoops, whoops. Wrong thing. Let's talk about that for a minute. We need to have an index that's stepping through our array list one at a time. Now that's something we didn't figure out in our table because we weren't really looking at the array list part of it. So let's add in an index. The index, of course, should be initialized to 0 because remember 0 is our first element in our array list. Array lists are 0 index, so we always start counting at 0. So while our index is less than addresses.size, the other thing I like to do right at the start is to increment our index. That keeps you from writing infinite loops. Now we're going to want to have that increment at the end. So the first thing we want to do is to compare our next element in the array to our previous one. So if addresses.get of index equals previous, notice that I'm using equals here because we're in the string class, so you don't use 2 equals sign to compare strings. If it's the same as the previous one, we increment current count. Current count equals current count plus 1. Then we need to check and see if we're now over the max value. So if current count is greater than max value, then max value equals current count and max count equals current count. Now we might want to think about where we're starting here. Because we started current count at 1, when we're doing our first comparison here, we're not going to find that the addresses of getIndex equals previous, and so that increment isn't going to be done. That actually is correct. But we do need to get set up for our next trip through the loop, and that is previous equals addresses.get of index. And we may be ready to go. Notice that we've gotten quite a few curly braces hanging around here. Some of them in the correct position and others not. So let's clean up that mess. The other thing I like to do when they get complicated like this, when you start getting a lot of nested statements, is to actually mention which curly brace we think that one is. This helps a lot in debugging later. So if current count greater than max value. This one, on the other hand, addresses equals previous, and this one is the end of the while statement. Once again, a few comments go a long way. Now, there's one thing that hasn't happened here, and that's that we haven't dealt with the case of what happens when our address is not equal to the previous one. So that's something we definitely have to consider. That's the transition between A and B in the example we worked. So else, when they're not, whoops. Okay, so I made a mistake there, but let's talk about it. I had 2 if statements, and I put the else with the wrong one. The reason I was able to spot that so quickly, by the way, was in part because I had the comments there telling me which else it was. So let's cut that out and move it down here. What if our next address is not equal to the previous one? Well, at that point, current count is going to equal 0. We're going to reinitialize it, and we're ready to go. So let's put a little comment in here to end the else. Then we set up our previous, increment our index. Looks like we've got a start. Now, we've got some complaints from Eclipse. Oh yes, well this is just a silly mistake. Max value is storing our string. So it should get addresses.get of index. And let's take a look at this one. So it says the operator greater than is not defined for the argument types int and string. Well, that's because I used max value instead of max count. Now, both of these mistakes are telling me something about my variable name that it might be smart to pay attention to. It looks like maybe it wasn't chosen very well because I made the same mistake twice of thinking it was max count instead of max value. If we continue to struggle with this code, that may be something we want to go back and change. The one thing we need to fix before we test this and see if it's working is our return statement. If we get to the end, what we should be returning is max value. That is the value that was found the most often. So let's now see if our code is running. Notice without having to type it in, oh, and we did something silly. So while we created the rest of the method, we forgot to do anything in the main program. Like, for example, call the method. So our method hasn't even run at this point. So here we go. Find common name from emails. And that result is going to be saved in a string. And then we're going to print it out. System out print line. The most common email was plus common. Now when we run our program, we should actually see something, which will probably make it more fun. So it says the most common name was Missy. 1, 2, 3, 4, 5. Looks good. Let's see what happens with a tie. Notice one of the things that's nice about using files for input is that it's very fast to run the program multiple times. You don't have all that boring typing in the same data over and over and over. You do have to remember to save the file though. If you don't save the file, the program won't know about it and it will run the old file. The problem there is that you'll spend time debugging a program that's working correctly. So saving that file is really important. So let's run again. Now the most common name was Susan. Well, let's think about what we did and see if that's the correct answer. So the 4 Susans are found before the 4 Missies. In our code, the place where we made that decision is actually right down here. So this line of code, line 32, is the one that tells us that the first person that gets to the count is the one that's going to be found. So in fact, this program seems to be working just great. So we can go through and check all of our test data, and I encourage you to do that. Remember to check the boundary cases. For example, one text. I think that's probably a good one to test right now. So we'll go back to our file. We remember to save it and run the program again. And that worked perfectly.